Video 1. Scalars and Vectors. Purpose. Foundation of Kinematics. Introduction. Physics does not begin with motion. It begins with measurement. In kinematics, before studying how objects move, we must understand how physical quantities are described. Some quantities need only a number. Some need a number and a direction. These are called scalars and vectors. This chapter is the foundation of kinematics. Scalar quantities. A scalar quantity is a physical quantity which has only magnitude and no direction. Magnitude means how much of a quantity. Examples of scalar quantities are distance, speed, mass, time, temperature. For example, if a person walks 10 meters, we only care about how much distance was covered, not the direction. Hence, distance is a scalar quantity. Vector quantities. A vector quantity has both magnitude and direction. Examples of vector quantities are displacement, velocity, acceleration, force. For example, if a person moves 10 meters towards the east, both distance and direction are important. Therefore, displacement is a vector quantity. Vectors are usually represented by arrows. The length of the arrow shows magnitude, and the arrowhead shows direction. Distance versus displacement. Very important. Distance is the actual path length travelled by an object. Displacement is the shortest distance between the initial and final position in a particular direction. Distance, scalar quantity, depends on the path. Always positive. Displacement, vector quantity, depends only on start and end points. Can be zero. If a person walks and comes back to the starting point, the distance is not zero, but the displacement is zero. Magnitude and direction. A vector is completely defined only when both magnitude and direction are given. If direction is missing, the quantity becomes a scalar. For example, velocity without direction is only speed. Thus, direction plays a crucial role in vectors. Vector addition, graphical method. When two or more vectors act together, their combined effect is called the resultant vector. One simple graphical method of vector addition is the head-to-tail method. In this method, the tail of the second vector is placed at the head of the first vector. The vector drawn from the tail of the first vector to the head of the last vector represents the resultant. This method helps us understand both magnitude and direction visually. Numerical example. A person walks 3 meters towards the east and then 4 meters towards the north. Find the magnitude of displacement. The two directions are perpendicular to each other. Using Pythagoras' theorem, Displacement equals square root of 3 square plus 4 square. This gives 5 meters. Hence, the magnitude of displacement is 5 meters. Conclusion. Scales and vectors form the base of kinematics. Understanding them clearly makes motion in a straight line, motion in a plane, and projectile motion very easy. In the next video, we will begin with motion in a straight line. Thank you.